Okay, so this is question number 10 of May-June 2006, paper 3. So in this question they say that the points A and B have position vectors relative to the origin O given by OA, which is -1, 3, 5, and OB, which is 3, -1, -4. The line L passes through A and is parallel to OB. The point N is the foot of the perpendicular from B to L. Now, if we were to draw a diagram, we would have a line L, which is passing through point A, and this line is parallel to OB, which is basically another line having point B on it. And we can assume that this point is our origin. So this is OB from origin, okay? And this OB is similar to this vector over here. And if I were to say OA, this is this vector right here. And then they say that there is a perpendicular from B to L. So if we were to just draw like this, a line, okay? So there's this line which is perpendicular from B to L, and the point N is at the foot of this perpendicular, so it will be right here, point N. Now we can start with part 1, which says that state a vector equation for line L. So we know that vector equation is usually consisting of two parts. One is the fixed point and the other is the direction vector for that particular line. So if I were to write a general equation, it's something like this. Now the reason why over here we're taking the direction of OB, why we're taking this vector direction with us, is because OB and this line L are parallel, so their direction vectors, they're the same. Because they're parallel, their direction vectors are same. So over here for the equation for line L, we can use the vector of OB in place for the direction vector of this line. So if we plug in the values, we're gonna see that line L for A will say -1, 3, 5 plus lambda. OB will say 3 -1 -4. So there, that's our first part. We're done with it. Now moving on to the second part, they say find the position vector of ON and show that BN is equals to 3. So what they're saying over here is that we have to show that BN, the length of this line BN, is equals to 3. And they want us to find the position vector of N, and by this they mean they want us to find ON. So ON would be this vector. So they want us to find this vector, and they want us to show that Bn is equals to 3. So we're gonna first this was part 1, and now we're doing part 2. So B so this line BN, okay, so if we are to break it down to its position vectors, it would be ON minus OB, right? And we have the value of OB, which is 3 minus 1 minus 4. And for ON, since this point N, it's lying on line L, so we can use our vector equation for line L as a general form for ON, right? Because lambda shows that it can be on line L on any position, like N can be here or here or here or here, right? So to find the exact location of N, we need to find this lambda. But for now, the general form of this ON can be taken as the vector equation for line N, line L, because N basically lies on line L. So that's what we're gonna do. We're gonna take this part right here, and what we're gonna do is that we're gonna open it up. So we're gonna get this thing, minus 1 plus 3 lambda, 3 minus lambda, 5 minus 4 lambda. Okay. Now, since these two vectors are subtracting from each other, we're gonna open this up and we're gonna work further on this. Lambda minus 4 minus lambda plus 4 minus 4 lambda plus 9. So this right here is basically our Bn vector. Now, we know that Bn is perpendicular to line L. So that means that the angle between these two is 90 degrees. So in the next step, we're gonna do this, to find lambda. And we're gonna take the dot product of this, which would equal to 0, and over here we're gonna take the direction vector for line L, which is (3 minus 1 minus 4). Okay, so now we're gonna write it like this: 9 lambda minus 12 plus lambda minus 4 plus 16 lambda minus 36 is equals to 0. Now grouping the like terms together: 9 lambda plus 16 lambda plus lambda minus 4 minus 12 minus 36 is equals to 0. (26 lambda is equals to positive 52, because all of these negative numbers 4, 12, and 36, they'll go on the other side and become positive, and we divide this by 26 by 26, so we get the value for our lambda, which is 2. So we've got the value for our lambda, and this value of our lambda, we know that our lambda is equals to 2. We're going to plug this value of our lambda in our equation for Bn, this part right here. So we can find this, the length of Bn, because they ask us in the question in part 2 to show that Bn is equals to 3. So we're gonna plug in these values. So we have got this, and now for finding this part, Bn, we're just gonna take 2 square plus 2 square plus 1 square is equal equals to 3. So, like in the question they stated, they wanted us to prove or show that Bn is equals to 3, and we have done that. We have shown that Bn is equals to 3, but there is one part of the question that we haven't figured out yet, and that is to find the position vector of n. So the position vector of n is obviously On. So we're going to go back, and we have On. This thing right here is our On. So this thing right here and this thing right here, they're both the same thing. Okay, so what I'm going to do is I'm going to plug in the value of lambda that we found out into this. So we have our position vector On here as well, which we know is 5, 1, and -3. So we are done with part 1 and part 2. Okay, now let's move on to part 3. Find the equation of the plane containing A, B, and N, giving your answer in the form ax plus by plus cz is equals to d. We have to find the equation of the plane. Okay, let's do it. So we have a plane, and we have some points, like we had line L with point A with point N, we had another line with point B, right? So now using these points, we're supposed to find the equation of the plane. And one way to do this, we know that the equation of a plane is like this. Okay, so what we're gonna do, where n, it shows the normal to the plane. So what we're gonna do, the first step is to find the normal to this plane, and how we're gonna do it is by forming two lines, AN and AB, and making a vector equation for both an and AB. And then we're going to do the cross product of these two equations to find out the normal.